Hello, let's continue our previous lecture. So let's move to the end of the code in the link. So going down and down. Okay, I think this is the most least one. Let's create a cleaner code. So let's copy this code, the most least one. Okay, copy most least one, copy cell, and then code, okay, paste over here, and then create another code cell, and then move this up, okay. Okay, this one is not necessary, so let me delete this one. So let's type exit, okay, so that I can create code from the beginning, okay. It delete all the previous variables, and then let's create another cell here. Let's import host of the library. So for example, from SciPy, from SciPy, and then optimize, right? Optimize, and then import fsolve. We use fsolve, okay, SciPy, and then let's import exponential function. So from math import exponential, and then let's import tabulate. From tabulate import tabulate, and run this one, and then run the previous code. Let me see whether it works. Okay, it works fine. Delete this one, and then let's make a clean version. So the first part seems right, but let me add m over here, the initial value, and then self m equals m. Okay, so here now we go to the code below. So here bond one, we have to import m over here. Okay, m as well. Okay, and then again this should work. Okay, so far so good. And then the second part, well, in this case, this m thing is a bit uncomfortable. So let me change this one as x. Okay, so this thing is, so let's change this one as x. Okay, so this is the first drift term, right? And then RD, and everything looks fine. Everything looks fine. And then self H0. Okay, looks good. Let me see it works. Good. And then third part, self M. Okay, this one. And then third part, I don't think now we need this part, right? We need this part, M0. Instead, you can simply solve fsolve with this one, and this one is M is from the previous one, so self M. Okay, so we actually use this one over here as a start value. So this is initial start value. Okay, and then it only serve no argument. Okay, now here, okay, we have correct part, and then let's define this one, M0 self. I don't think we need this one, so delete this one, and instead of this one, we can add self dot M0, and since it doesn't need any argument now, I can simply put empty one over here. Okay, and then now this RD, because it is optimized one, so let's save into the self, and it is the self, and then RD self. Okay, let's use this one. And then about this one, this M is computing, so let me change it to the X over here. So this is second period draft, so this looks fine, fine, fine. They all looks fine. And then, okay, let me check it. Oh, so there is error, so I don't need this part. Okay, and then M0, we don't need this part. And then to answer, there is still errors. I don't know where it is. Okay, RLD M0. Okay, RLD part over here. RLD M0. Okay, this one. Okay. One, two are given. Okay, so let's change one by one. M0 print. Okay, let's change one by one. Okay, so this part. Okay, actually we don't need this part 0. Okay, so this part doesn't need it. Okay, now everything is clean. So where did you stop? Okay, here. So X over here. So everything looks fine. Okay. Now this M1 part again, we can use initial value. Okay. So here, but initial instead of, so this is the basically second period drift. So for initial guess, let's use the first period initial guess. So which is self M0. Okay. First period initial guess. Okay. So we can reuse our first period estimator. And then now we have a path of R here. And then we have self, self, self. And then RD and RU. Okay. RU and RD, because we already defined this. So instead of this one, we can simply add self.RD here, self.RU. Because, and then let's define this one. Okay. RD as another self. Self RDD, and then less RDD equals self RDD. And here, self RTU and less RTU equals self RTU, because I want to make notation simple. So self RUU and then self.RUU is too long. So let me change this one into what? I can change it to RUU equal self RUU. Okay. And then here, now I can delete this part and then delete this one M1 over here. Okay. Okay. Everything here. Where is error? Here. Okay. Now we don't need this part. M0, M1 self. So here again. Now and then good, good, good. Okay. Our path. Well, maybe we can, I think here it is a bit long. So instead of defining new variable like this, I think it is maybe better to just put self everywhere. Let's try the self and then self, self, self. Let me copy and then paste, paste, and then TT. I don't need this one. DT self DT for, okay, let me delete this one and delete this one. I can delete this one too. But now instead, I have to put self everywhere and then self over here for self for DT. Okay, and then delete this one. I have a self over here. And then self. Okay, I made it shorter, but well, it becomes shorter, but I had to put self everywhere. Okay, so there is a trade-off. Okay, and then okay, we defined our path, and then here 6 months rate, 6 months. Okay, well now it is a 6 months bond for 6 months bond. Now again, let's delete this one. And RD is actually, we defined it already, right? So actually, we don't need this, but we don't need this part. Okay. And then here we have self, and then self, and then this one self, R0, and then let's see whether I have everything. This looks okay, and then run it. Okay, it looks okay. And then about 9 months are those things I already defined it, RUU, everything. So I think I can delete this one entirely. And this one, self, 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 self over here. And then RU, RD. Okay. I think there are no mistake over here. Actually, in the middle of the code, okay, I pick copy and pasted this one. We need this one. I need this one and this one. But here, okay, I don't need this one anymore because we can generate them anyway in the class. Right. So delete everyone. And then tabulate. We don't need this one. Okay. Actually, everything is now class. So delete this one. Good. Okay. To check it, let me restart everything again. And then run it. Now there is error. RD is not defined. RD is not defined. Where? Over here. Okay, I have to put self over here, and which is missing. So 29 here, right? So self. Actually, I can delete everything over here, this one as well. And then safely, I put self everywhere. This one, self. Okay. LTD, and then we need a put self over here, and then this one, okay. This is a bit uncomfortable because I put self in too many places. Okay. Okay, we have our past 6 months and then 9 months bond. 9 months bond is everything looks fine and you. Okay, so I think we have now cleaner one, self-M. But okay, here about R pass, actually we don't need this one, right? R pass. M is not necessary because, all right, we don't need initial value. Here we don't need initial value either. And here M is not used, so we delete it. And then we will have a bunch of error, but here now I can delete everything because we don't need the argument anymore. So everything looks fine, but let me check it finally to restart, exit, and then run this one again. In fact, I think I can move entire this thing over here, okay? Delete, and then right below the exit, actually, I think, so that I don't have to click 2 times. Okay, so everything looks fine. So here, M initial value, 3 months rate, 6 months rate, NTT 3 months, volatility given, and then we define 2 bond price and about the bond estimation. Okay, in the whole class, in the class whole, class name whole, I put R0TT for the A, the series of bond prices, and our initial gate. And then I calibrate our first period drift term and second period drift term. Drift term over here and tabulate, calibrate the path of interest rate. Okay, so here, check input bond prices of LSD. Okay, then we will have a path of interest rate and then 6 months bond, 9 months bond. So first period drift term. Okay, I need term over here. Okay. Okay, first period drift term, this one, second period drift term. And then we have calibrated the path of interest rate, and we have bond price, evolution of bond price consistent with this path of interest rate, which is the 3 months bond, no, 3 months, 6 months bond, and then 9 months bond, and then this model calibrated bond prices are equivalent to, same to our IPO bond price. So everything looks fine. So one possible homework is the homework, possible homework, print, okay? Print one possible homework, it would be create BDT, Black Diamond Toy model version for this code, of this code. Now I think you can do that. We have this code. This is not long. You can slightly modify this code, this part of the code, and then you can create Black Diamond toy model version of this code. That would be an interesting exercise. Thank you.